All right, everybody. So today we're going to look at evaluating limits algebraically. So we're going to learn all this algebra, or many of the steps that you need to use to solve a problem. Now, in our first case, we have a limit problem. As x approaches 2, and the function we're evaluating is x plus 3. So to begin with, always the very first step that we do is direct substitution. You check for direct substitution. If it works, then you have your answer. And we're going to look at a couple cases where it won't work, and what are we going to do? So the lim as x approaches 2 of x plus 3, you just directly substitute 2 for x plus 3, and we get 5. That's all it is. If we have an example, for example, lim as x approaches 1 x squared plus 3x plus 2 equals, once again, direct substitution. So it's 1 squared plus 3 times 1 plus 2. We end up with 1 plus 3 plus 2. And 1 plus 3 is 4. 4 plus 2, we get 6. And that's all it is. Evaluating limits. We're using algebra. Right now, the first step, these problems are very basic, so we just use direct substitution. So now we're going to look at a slightly more complicated problem. Let's look at a case where we have a fraction. The lim as x approaches 2, 1 over x minus 1/2 divided by x minus 2. Let me clean this up a little bit. Now here we're going to use some extra steps here. And I've already reviewed in previous videos the fractional method for doing a problem like this. So when we look at a problem, we ask ourselves, do we factor? Do we use some other algebra? If we don't see radicals, we don't use conjugation. Now, when we do a problem, a lim problem, we do direct substitution. So let's see what happens. If we directly substitute, I have 1 over 2 minus 1 over 2 over 2 minus 2, and we end up with something called 0 over 0. What is that? It has a name for it. It's called indeterminate. So we still have some more work to do on this problem. So we checked for it, we did direct substitution, we can't come up with an answer. If we see fractions, in this case, we're going to use our technique for adding fractions together. So write the problem over again. Lim as x approaches 2, 1 over x minus 1/2 x minus 2. We just double check, make sure that's what we wrote, and that is in fact. So let's begin. Equals. Always state the lim problem again. X minus 2. Now, we're going to multiply the denominator here. We're going to multiply this 2. We want to multiply this 2 times the 1 in the numerator. And allow me to just pull up the colors so that you can see it. So when I speak of 2, I'm talking about this 2. So we're going to use a method like this. These arrows mean to multiply. All right, so the first step is to multiply x times 2. that x times that 2. And x times 2 is going to be 2x, so I write it. That was step 1. Now, what do we have to cross multiply? So I get 2x, put a line. Matter of fact, let's bring our problem down a little bit so that's have some more room here. So I'll actually work across the page. Lim as x approaches 2, I'm going to get x minus 2. And once again, x times 2, we get 2x. And in the numerator, for step 2, we're going to multiply 2 times 1, and we get 2. X times 1, we get x, put the sign in the middle. All right. Now we're going to simplify a little bit. Equals lim as x approaches 2, x minus 2. And in the numerator, I'm going to, let me rewrite this over a little bit. I want to split this up into 2 fractions. Equals lim, and I'm going to show you this. So remember when we had from algebra complex fractions, a over b over c over d? The way we simplify that was just a over b times d over c. You the reciprocal. So in this case, I'm going to use this step here. This is really 2 minus x over 2x over 1 over x minus 2 divided by a 1 there. So going back to our problem, I'm going to write 2 minus x over 2x times 1 over x minus 2. That's what I'm going to do. Okay? So equals lim as x approaches 2. Go right. We're going to write 2 minus x over 2x. 2 minus x over 2x times 1 over x minus 2. And we're going to just double check 1 over x minus 2 is right. So we just have to keep checking, make sure that we're all right. Now, once again, if we did direct substitution here, we would still end up with 0 over 0. So that tells us there's something that we have to do. There's an additional step. And I'm going to show you this algebra that will help us in this problem. So you could do this with the numerator or the denominator, but what I'm going to do is just work with the numerator. So I'm going to write lim as x approaches 2. Now I'm going to put minus x plus 2 over 2x times 1 over x minus 2. Can I do direct substitution? If I did, I would still get 0 because I would get 0 here, 2 minus 2. We can't divide by 0, but this here would be a 4, and this would end up giving us a 0. So we still cannot solve this problem in this form. But there is something interesting that we can do. Lim as x approaches 2, I'm going to factor out a minus sign, and look at what I'm left with. Now, can we cancel? We sure can. This x minus 2 and this x minus 2 cancel. And I am left with minus 1 over 2x. Now I can substitute. Equals minus 1 divided by 2 times 2. Notice that when I did direct substitution, I did not continue to write lim. Equals minus 1 over 4. And that's it, everybody. That's a very nice technique to use with these problems, and they work all the time.